Good morning, everyone. Welcome to Wednesday, April 22nd. Today, we are going to essentially review everything that we have done so far when it comes to factoring. In your assignment for today, you're going to see a lot of attachments. The first attachment that I want you to focus on is this one right here. How do I factor the expression? It's called like a mind map or a diagram. So this is the thought process that you're going to go through from now on when you're asked to factor an expression. So while we're going through this video, make sure that you have this. If you have a printer and you can print it out, great. If not, just have it open on your computer so that you can see kind of what we're looking at. So I'm going to pull it up on my computer as well. Again, this is the thought process we're going to be using when it comes to factoring. The second attachment that you're going to see is today's worksheet practice. For this worksheet practice, we are going to do the odd numbered problems together. So there are 16 total problems. We are going to be doing the odds, which means we're going to be doing 8 problems together on this instructional video. In addition to the video, I'm going to take pictures of the work that we do and then attach them as well. So in addition to the attachments that you see of the mind map or diagram and the worksheet practice, you're also going to see 8 attachments of worked out problems. So once you have all of this out, and if you don't have a printer, that's fine. Go ahead and write down all of these problems on pieces of paper, and then you can follow along kind of as we go. Now, you'll notice that I don't give you very many instructions on this worksheet practice. All I do is I kind of try to mimic what the diagram, what the flow chart is. So in the flow chart, step 1 is look for a GCF. Step 2, identify number of terms. And then based on the number of terms, you pick a factoring method. In the worksheet practice, same thing. Step 1, look for a GCF. Step 2, identify number of terms. Step 3, choose a factoring method and factor. So we're going to go through that process, and then I purposefully made sure that the examples mimic the practice problem that you're going to do. So number 1 is very similar to number 2, number 3 similar to 4, 5 similar to 6, and so on and so forth. All right, so without further ado, we are going to get started with worksheet practice number 1. Okay. So as you can see on the whiteboard here, I've included the same 3 instructions that you see on your worksheet practice. Part 1, always look for a GCF first. This is essentially crucial. Like, I cannot stress that enough. Look for a greatest common factor. See if there is a common factor among all of the terms. Step 2, identify the number of terms, which then you can go to your flow chart, and based on the number of terms, you pick your factoring method. So question 1, 2m squared plus 10m. Step 1, look for a GCF. Is there a greatest common factor among 2m squared and 10m? Well, 2 things stand out to me. 1, I know that 2 goes into 10, so that tells me 2 is a common factor. And the second thing is that both of these have a variable. Both of them have m in common. So in this case, yes, there is a GCF. And that means that we're going to do that work first. So to start our factoring process, we're identifying the GCF of these 2 terms. We already determined that the GCF of 2 and 10 is 2. So I'm going to write these using as products using 2. So 2 is 2 times 1, and then m squared is m times m. 10 is 2 times 5, and then there's an m as well. Now, some of you won't have to do this step, but you might be good enough now that you don't have to. You could just jump straight to the factoring. For those of you who need it, our next step is find what they have in common. So they have a 2 in common, but they also have something else in common, m. So that means that our greatest common factor here is 2m. And whatever they have in common, remember, can be pulled out in front. Now, our final step is once you take out that greatest common factor, what does it leave you with? So when I take out 2 and m from the first term, I'm left with 1 times m. And when I take out 2 and m from the second term, I'm left with 5. Now, this might seem okay to you, but if you remember, your Algebra 2 teachers one day are not going to like this. Can you see why that might be? I think it's because 1 times m can be written just as m. So keep an eye out for things like that. All right, so we have done factoring with the GCF. Let's go through our next 2 steps here. Step 2, identify the number of terms. When we say identify the number of terms, we're looking for what's inside of the parentheses if there was a GCF. So technically, this is a single termed expression. This is a product. I'm asking identify the number of terms left in the group. So there are 2 terms left in this group, which means it is a binomial. So if we look at our flow chart, when it is a binomial, we have 2 options. First, is it a difference of 2 squares? So that's what we've been looking at earlier this week. So looking at this expression, m plus 5, is that a difference? No, it's a sum. So automatically we know it's not a difference of 2 squares. So let's go to the next one. If it's not a difference of 2 squares, guess what? You are done after you factor out the GCF, meaning this cannot be factored any further. You are done. You have fully factored a 2-termed binomial and you didn't even have to do an additional step. You're absolutely finished. So once you've done number 1 and you've copied it down, go ahead, pause the video now, try number 2, check it with the answer key, and then we're going to go ahead and look at number 3. All right, hopefully you didn't have any issues factoring number 2. Now let's take a look at number 3. Step 1 is always look for a GCF. So among all 3 terms, is there a greatest common factor? So x squared only has the factors x and x, meaning that already shows me that unless these 2 terms have an x, there is no greatest common factor. Does x go into 10x? Yeah, but does 16 have an x? No. Like you might notice that 10 and 16 have a common factor. They have a common factor of 2, but does 2 go into x squared? No. So in this case, no, there is no greatest common factor. So that just tells us that because there's no GCF, we're just gonna move right along, okay? Step 2, identify the number of terms. Well, because we didn't factor out anything, it still has the same number of terms. There's no parentheses like we had in example 1. So how many terms do we have here? We have 3 terms. All right, now let's take a look at our flow chart. When you have 3 terms, there's 2 questions that you're going to ask yourself. Question 1, is there a leading coefficient, okay? Or is one question, 2 possible answers. Is there a leading coefficient? If there is no leading coefficient, you're just gonna factor with P's and Q's. If there is a leading coefficient, then it becomes a little bit more complicated. Remember, leading coefficient is a fancy way of saying number out in front. So let's take a look and see, does this have a leading coefficient? Do you see a number out in front? No. That tells me, if we look at our flow chart, we're going to use P's and Q's. All right, so factoring using P's and Q's means find 2 numbers that have a sum of the middle term and a product of the last term. So what times what is 16, that when I add them together, I get -10. Now remember, if your sum is negative and your product is positive, that tells you that both of your numbers are going to be negative. So, oops, I skipped a step. Actually, I'm sorry. Let's go back for a second. Set up your answer as a product of 2 binomials. What times what is x squared? That's going to be x times x. There we go. I forgot that step. All right, over here, I'm thinking -4 and a -4 would be -8. That doesn't work. What about -2 and -8? -2 and -8. Yeah, that works. -2 times -8 is 16. -2 plus -8 is -10. So we pop over here. Our 2 terms are -2 and -8. And guess what? You are done. This is a fully factored expression. You took something that was a sum and a difference, you changed it into a product, and voila, complete. All right, go ahead and pause the video now once you've had a chance to go over this and try number 4. When you come back, we're going to be going over number 5. Okay, up next, we're going to do number 5, 6x squared plus 54x minus 60. Same steps, same first question. Step 1, look for a GCF. So immediately what stands out to me here is that we do have a leading coefficient. There is a number out in front, 6. So the best way to check is check the leading coefficient, see if it's a factor of the other two terms. That's just a little trick that tends to work sometimes. So in other words, does 6 go into 54 and does 6 go into 60? I know 6 goes into 60 10 times. Let's use some technology, since you have it, to see if 6 goes into 54. Yes, it does. It goes in 9 times. So in this case, yes, we have a GCF. And in the GCF in this case is just going to be 6, because even though the first and the second term have an x, the last term does not. So for this, we're going to factor out 6 first, and what is that going to leave us with? Well, let's see. 6 times what is 6x squared? That's x squared. 6 times what is 54x? That's 9x. And 6 times what is 60? That's 10. So step 1 complete. We found the GCF. It was 6. Are we done? No. If you look at your flow chart, step 2 is identify the number of terms. So in this case, because we have looked at a GCF, or we have factored out a GCF, our next step is look inside the parentheses to find the number of terms. So if I look inside here, 1, 2, 3, I have 3 terms still in my expression, in my parentheses. So we go back to our flow chart. That is 3 terms, means that this is a trinomial. So we're going to ask ourselves the same question that we did last time. In a trinomial, does it have a leading coefficient? If it doesn't have a leading coefficient, we're just going to factor with p's and q's. If it does have a leading coefficient, it gets a little bit more complicated. So let's look. Does our expression have a leading coefficient? Remember, the 6 is no longer part of our trinomial. So that is not considered a leading coefficient. That's just a factor. That's step 1 of factoring. That's just the GCF. So looking here, x squared plus 9x minus 10, is there a number in front of x squared? No. If there's no leading coefficient, that means we use p's and q's factoring, just like we did in number 3. What two numbers have a sum of 9 and a product of negative 10? So what times what is negative 10? So when I add them together, I get positive 9. Okay, so 2 numbers that multiply to negative 10, the first that comes to mind are 5 and negative 2, but I don't think there's any way to add 5 and negative 2 and get 9. Something that might help here is, if you notice, 9 is only 1 away from 10, which is a little bit of a hint. It's telling you that 1 is going to be one of your factors. So let's try negative 10 and 1. Okay, negative 10 times 1 is negative 10, but negative 10 plus 1 is negative 9, not positive 9. So that didn't work. Let's try, we did negative 10 and 1, so let's try 10 and negative 1. 10 and negative 1. 10 times negative 1 is negative 10. 10 plus negative 1 is 9. That seems to have worked. So I forgot to do that step of setting up. So when I set up, 6 is still one of your factors. 6 doesn't go away. Set up your product of 2 binomials. X times x is how you get x squared. And then the last step is bring in your p and q. I have positive 10 and negative 1. 10 times negative 1 is negative 10. X times x is x squared. 10 plus negative 1 is 9. And when I multiply all of these by 6, I end up with what I started with. And that's how you know you are fully factored. Most common mistake here is to forget the 6. You have to keep in mind what your original expression was. My original expression had 6 as a factor of all 3 terms, which means my answer has to have 6 as that factor as well. Now that you've seen number 5, go ahead and try number 6, and then we're going to go on to number 7. Okay, moving right along to number 7. We are about halfway through our worksheet practice at this time. Step 1, look for a GCF. So we've got some pretty big numbers here, which usually leads you to think that there is a GCF. So when I look at 40, I'm thinking, you know, 4 is a common factor, 5, 8, 10. Let's see, 5 goes into 15, but it doesn't go into either of these, so that doesn't work. 4 goes into these two, but it doesn't go into 15, so that doesn't work. 3 goes into all of these, but not into 40. I don't know that we have a common factor here. I don't think that we do. We have some common factors among some of the terms, but not all of the terms. So the answer to our first question, is there a GCF here? No, no GCF. So let's take a look at our flowchart. According to our flowchart, the next step that we're going to do is identify the number of terms. 1, 2, 3, 4. We have 4 terms, which means we call this a 4-termed polynomial. Take a look at our flowchart here. So no GCF, we identified the number of terms as 4. So according to our flowchart, the only way we can factor a 4-termed polynomial is by grouping. That's it. There is no other way. And in fact, I gave you a little example here. In grouping, you put, first step is to put both binomials in groups. So group the first 2, group the last 2. Second step, factor out the GCF of both. You have to have a common binomial factor in order for this to work. And then the third step is to put it as a product of 2 binomials. So now that we've identified that it is 4 terms, we know the only thing we can do is factor by grouping. So here we go. Step 1, let's go ahead and put our 2 groups in. So first 2 terms go in the first group, 40b cubed plus 15b squared. Remember, when we're doing our grouping, whoop, almost knocked that whole thing over. When we're doing our grouping, you can only put groups in if it's a sum. So because this is subtraction, that negative goes with that second term. I'm going to turn this a little bit so you can see it better. So that inside our second group is negative 48b minus 18. So step 1, group. Step 2, find a GCF. So if I look at 40 and 15, I'm going to think about the factors of 15. Always start with the smaller one and then see which ones are factors of 40. Factors of 15, 3 and 5, 1 and 15. Well, 15 doesn't go into 40, but 5 goes into 40. So I'm going to use 5 as my GCF here. So 40 is 5 times 8, and then b cubed is b times b times b. 15 is 5 times 3 times b times b. So I'm just writing them both using 5 and obviously with the b's. Simultaneously, let's go ahead and do the same step for the second one. So again, I'm not going to start with the factors of 48. I'm going to start with the factors of 18 because it's the smaller number. So as long as it's a factor of 18, it'll be a factor of 48. The factors of 18 that stand out, 1 and 18, 2 and 9, 3 and 6. Let's go from the top and work our way back down. 18, I don't think goes into 48. 9 definitely doesn't go into 48. 6 goes into 48. I believe 6 goes into 48 8 times. Now, because this is a negative, that means that we're going to factor out a negative 6. So the greatest common factor has to be negative. Negative 6 times 8 is 48 times b. And then the second factor is negative 6 times 3, because a negative 6 times a positive 3 is how that becomes negative. Okay. What was our GCF? So in the first one, we knew at least 5, but they also have b times b in common. They have a b squared in common. So in the first one, we're going to factor out 5b squared. When we do that, what does it leave us with? Let's see. It leaves us with, if I take out the 5b squared, in the first term, I'm left with 8b plus 3, because I'm left with 3 in the second term. So remember, this is the binomial that we're also trying to get over here. If we don't get that common binomial factor, we can't continue. So let's look in the second term, or in the second binomial. They have negative 6 in common. So minus 6, pull that out in front. Once I take that common factor out, I'm left with 8b and a positive 3. Do a quick distributive if you want to check. 5 times 8 is 40. B squared times b is b cubed. 5 times 3 is 15, b squared. So the first one looks good. Negative 6 times 8b is negative 48b. Negative 6 times positive 3 is negative 18. Second one looks good. All right, final answer. We are going to pull out our common binomial factor, 8b plus 3. And then this is the part that some of you had expressed that you were struggling with. What is the second binomial? The second binomial is the combination of the two GCFs. So what was the GCF of the first two? 5b squared. What was the GCF of the second two? Negative 6. Voila, you are done. So again, there was no GCF here. It had 4 terms. So our factoring method was just to do grouping. Go ahead and try number 8. Number 8 is very similar to number 7. And then we will go ahead and look at number 9. All right, number 9. So now we are on the second page of the worksheet practice. Hopefully you've been able to do 2, 4, 6, and 8. And then from now on, or from here on out, we'll go through the rest of these. So the second page is definitely more challenging than the first page, but we should be able to do it no problem as long as we're going through this process and using our flowchart. So here we go, number 9. 3n squared minus 19n plus 20. Step 1, look for a GCF. There is a leading coefficient here. So what if you remember from, I think it was number 5, check to see if that number is a factor of the other two. So does 3 go into 19? No. Does 3 go into 20? No. So in this case, there is no GCF. Okay, identify the number of terms. 1, 2, 3. This has 3 terms. So let's take a look at our flow chart. All right, there was no GCF. We identified it as having 3 terms. So remember, when it's a trinomial of 3 terms, you're looking for, does it have a leading coefficient? Looking at my expression here and having it on your paper, I noticed that this has a leading coefficient of 3. So I'm not going to use P's and Q's. P's and Q's is only the method that you can use if there is no leading coefficient. See how there's no number here in front of X. So we're going to scroll down here. We know that there is a leading coefficient. The leading coefficient in this case is, in this example, is A. In our example, it is 3. So let's take a look at our options. Step 1, is it a perfect square trinomial? If you remember, you don't have to do this. You could totally skip it and go to one of these methods, but it can actually save you time and energy if it happens to be a perfect square trinomial. In a perfect square trinomial, the first and the last terms are perfect squares. Let's see. Is 3 a perfect square? No. And neither is 20. So in this case, is this a perfect square trinomial? No, it's not. Well, that doesn't mean that we can't factor it. It just means that we're going to have to factor it using one of these 3 methods. You can either use supergrouping, double cross, or slip and slide. It's totally up to you which method you want to use. I happen to be a fan of this one. I really like slip and slide because I personally am better at P's and Q's than I am at supergrouping. So what I'm going to do is in this video, I will do this using slip and slide, but I will also post a picture of it done using supergrouping. I don't know many of you who are fans of double cross. So if you would like to see this done with double cross, send me a message or we can go over it in our video conference later on. So for today, I'm going to use slip and slide. It happens to be my favorite method. I just learned it like in October or something of this year. So here we go. So our factoring method that I'm choosing is slip and slide. And then again, what I will do is when I pause the video on my end, I'll also do it with supergrouping and I'll take a picture and attach it to this so you can see. All right, slip and slide. So if you remember, the first step of slip and slide is flip. I'm going to take the 3, the leading coefficient, and flip it down to the end and multiply. 3 times 20. 3 times 20 is 60. So now I'm working in this alternate universe of slip and slide. So I'd like to put my new trinomial in quotations because it's not the same trinomial. Once I slipped the 3 down, my trinomial became n squared minus 19n plus 60. Now, here's the interesting thing. This is still a trinomial, but what changed? There's no more leading coefficient. If you go back to your flow chart, what happens when there's no leading coefficient? Now we get to factor using P's and Q's. So that's the nice part about slip and slide, is it takes it from having a leading coefficient to this alternate universe where there is no leading coefficient. All right, now we get to play the P's and Q's game. What two numbers have a sum of -19 and a product of 60? So what times what is 60? That when I add them together, I get -19. Now remember, if the sum is negative and the product is positive, it's kind of hard for you to see that. If the sum is negative and the product is positive, that means both of my numbers are negative. So I know I'm looking for two negatives here. I'm going to go ahead and set up my two binomials. Okay, and I know my first term is going to be n. Okay, how about negative, what goes into 60? -6 and -10, those add up to -16. -2 and -30 add up to -32. What else goes into 60? Oh, what about -4 and -15? Yeah, because 15 times 2 is 30, 30 plus 36. Yeah, that works. We have -4 and -15. By the way, feel free to always use a calculator if you can't figure it out. Like, just try numbers, who knows? That works though. So my two numbers are -4 and -15. Now remember, this is the factored form of this trinomial in this alternate universe. Had we been given this trinomial to start, we would be done. But there's a reason why it's in quotations, and there's a reason why this is called slip and slide. We slipped, now we have to slide, and we're going to take it out of this alternate universe and bring it back. So the number that we slipped was 3. Now we're going to slide it back underneath and simplify the fractions if possible. So here we go. Can I simplify 4/3? I don't think so. So if you can't simplify it, then you just continue on and slide that number in front. So my first binomial becomes 3n minus 4. Okay. And the second one, can I simplify 15 divided by 3? Yeah, 15 divided by 3 is just 5. So my second binomial is n minus 5. Let's do a quick check here. Does 3n times n equal 3n squared? Yeah. Does -4 times -5 equal +20? Yeah. And then here's how you can check the middle term. Ready? 3 times -5 is -15. -4 times 1 is -4. What's -15 plus -4? -19. So there's my check, and I am done. So again, there was no GCF. There were 3 terms, and the leading coefficient was not 1. Because the leading coefficient was not 1, we had to choose either slip and slide, supergrouping, or double cross. Oh, and it wasn't a perfect square trinomial because these are not perfect squares. So I chose slip and slide because that's my favorite method. Instead of going over supergrouping in detail, I will attach a photo of it. So go ahead and try number, 10. Try number 10 from the worksheet practice on your own, and then we'll come back and do numbers 11, 13, and 15. All right, number 11 with 3 more to go. 6m squared minus 28m plus 30. This is the one that is going to require the most amount of work. And I can tell because looking at it, I see that it does have a GCF, but the GCF is not 6, which means not only are we going to factor out a GCF, but we're also going to have to pick a longer method of factoring. But that's okay. We're going to do it anyway. So step 1, look for a GCF. Always check the leading coefficient. 6 goes into 30, but does 6 go into 28? No, it doesn't. So find a different number that goes into all 3. So something that stands out to me is that all 3 numbers are even, and all even numbers have a common factor. That common factor is 2. 2 goes into 6 3 times, 2 goes into 28 14 times, and 2 goes into 30 15 times. So we're going to start off by factoring out 2. Why is it that we do a GCF? Well, by factoring out 2, all 3 of these numbers will become smaller, meaning that they're easier to deal with, and our methods for factoring actually become easier as well. So once I factor out 2, what do I have left? 2 times 3 is 6, so I have 3m squared left as my first term. 2 times 14 is 28, so I have minus 14m as my second term. And 2 times 15 is 30, so I have plus 15 as my third term. Notice, I don't know about you, but I'd rather work with 3, 14, and 50 than 6, 28, and 30. All right, step 1 complete. There was a GCF. Identify the number of terms you have left. So again, we're looking inside the parentheses and counting. 1, 2, 3. I have 3 terms left. So let's take a look at our flow chart here. All right. Oh, look, it's already up there. So I have 3 terms. It is a trinomial. Is there a leading coefficient? Yeah, 3 is in front of the m squared, which means I can't just use p's and q's. Is it a perfect square trinomial? Let's take a look. Is 3 a perfect square? Nope. Is 15 a perfect square? Nope. So this is not a perfect square trinomial, which means that we have 3 options again: supergrouping, double cross, or slip and slide. Again, my favorite method is slip and slide. That's kind of what I gravitate toward. So to keep this consistent, I'm going to do this as slip and slide. And then like I did with number 9, I will attach a photo of the work done with supergrouping. So again, I'm going to do slip and slide. All right, here we go. First step in slip and slide, slip the leading coefficient down to the end. 3 times 15, which is 45. Now we are working in that alternate universe, but here's the thing, that 2 is still there. So when you're working in that alternate universe, you still have that 2. M squared minus 14m plus, this became 3 times 15 is 45. So don't forget that 2, that's still part of your factor. All right, now that it's a trinomial with no leading coefficient, I can do p's and q's, which I'm better at, which is why I like to do it this way. What 2 numbers have a sum of negative 14 and a product of 45? Did I do that right? Yeah. Okay, so what times what is 45? So when I add them together, I get negative 14. Ah, we have another one where the sum is negative and the product is positive, which means both my numbers are going to be negative. What goes into 45? How about 3 and 15? Negative 3 plus negative 15, that's definitely not negative 14. 5 times 9? Yeah, let's try that. Negative 5 times negative 9. Does negative 5 plus negative 9 equal negative 14? Yeah, it does. So we have negative 5 and negative 9. All right. So I'm bringing this down. Again, 2 is still part of it. Don't forget about that 2. Then I'm in my alternate universe here. M minus 5 and m minus 9. Where did I get the 2 m's from? M times m is n squared. Negative 5 times negative 9 is positive 45, and negative 5 plus negative 9 is negative 14. But that's the slip. Don't forget, the last step is to slide the 3 underneath both of these terms and simplify the fractions if possible. Does the 2 come along for the ride? You bet the 2 comes along for the ride. The 2 is still part of our original expression. Remember, we factored it out first, but don't lose it. Keep it with you. Now we're taking this out of the alternate universe and bringing it back. So can I divide 5 by 3? No. Can I simplify 5 divided by 3, or 5/3? No. So we're going to continue to slide that 3 out in front. Our first binomial is 3m minus 5. And then can I simplify 9 divided by 3? Yeah, 9 divided by 3 is 3. So let's see, 3m times m is 3m squared. Negative 5 times negative 15 is, times negative 3 is positive 15. That's 3 times 1 is 3. Negative 5 times negative 3 is 15. 3 and 15. Oh, excuse me. 3 times negative 3 is negative 9. Negative 5 times 1 is negative 5. Negative 9 and 5 is negative 14. Sorry if that confused you. Multiply each of these by 2. You get what you started with. or you could just check the answer key. Why wouldn't you just do that? All right, so again, this was a trinomial. We started with factoring out the GCF because it made everything smaller. And by the way, if you don't factor out the GCF, you're gonna have to do it at the end, and our brains tend to shut off when we get to the end of something. So most likely won't even do it. There were 3 terms. We did have a leading coefficient, so we chose slip and slide, or I chose slip and slide. Ended up with 2 times 3m minus 5 times m minus 3. Again, I will post a photo of the same exact problem done using supergrouping, and you can use pretty much whatever method you want after that. Go ahead and try number 12, and then we'll come back and do 13 and 15. 13 and 15 are special, which means that they aren't going to actually take as long to do. All right, almost done. We have 2 more to go, and these 2 will actually be the quickest because, like I said, there is something a little bit special about them. So let's take a look at our first one, number 13. 9x squared plus 24x plus 16. Step 1, let's look for a GCF. Does 9 go into 24 or 16? No. Let's try a factor of 9. Does 3 go into 24? Yes. Does 3 go into 16? No. So because all the factors of 9 don't go into the other 2, there is no GCF here. So let's just identify the number of terms. 1, 2, 3. We've got 3 terms. So looking at our flow chart, if we have 3 terms, that makes this a trinomial. Does it have a leading coefficient? Yes. 9 is out in front, which means we can't use P's and Q's. Is it a perfect square trinomial? Is the first and the last term a perfect square? Let's see. Is 9 a perfect square? Yes, it is. Is 16 a perfect square? Yes, it is. So if you remember with perfect square trinomials, the first and the last term have to be perfect squares, but that middle term has to be the sum of the product of the square root of the first and the last term. It's like, what is she talking about? Let me show you what I mean. We start by, because if the middle term is not that sum, is not 2 times the square root of the first times the square root of the last, then this is not a perfect square trinomial. We got to do something like supergrouping or what's it called, slip and slide. So let's see. Take the square root of the first term. Square root of 9 is 3. Square root of x squared is 3x. So 3x is the square root of the first term. Take the square root of the last term. Square root of 16 is 4. Now we're going to multiply these together and add them up and see if it gives us 24. And if it does, then factoring this will only take 2 steps. 3x times 4 is 12x, and 12x plus 12x is, look at that, 24x. So this is a perfect square trinomial. So that means we get to factor this in 2 steps. Step 1, set up your 2 binomials. The first term of your binomials is the square root of the first term, which we already found to be 3x. The second term in your binomial is the square root of the second term, or the last term, which we already found is 4. Now, how do we know if this is addition or subtraction? You look right here. Was the middle term positive or negative? Oh, look, the middle term is positive, which tells us that both of our binomials are positive. Now, what does 3x plus 4 times 3x plus 4 actually mean? It means 3x plus 4 squared. And that's your final answer. Did you have to do it this way? No, you could have done supergrouping, you could have done double cross, but again, that requires you having to multiply 9 and 16, and that creates a pretty big number where if you would just realize that these are perfect squares, you could do this a lot simpler. So go ahead and try number 14. I will give you a hint. Number 14 is a perfect square trinomial because 1 is a perfect square. All right, go ahead and try that, and then we'll come back together for number 15. All right, last problem of this crazy worksheet practice. So step 1, look for a GCF. The 2 terms here in this expression are 25x squared and 1. Let's see, does 25 go into 1? No. Does 5 go into 1? In fact, the only number that these have in common are 1, and 1 can't really be considered a GCF with something like this, so no. No GCF here. Identify the number of terms. 1, 2. 2 terms. Let's take a look at our flow chart and see what we can do. Okay, 2 terms means it's a binomial. So first we ask ourselves, is it a difference of 2 squares? So is it subtraction? And are the first and the second term both perfect squares? Let's see. Is it subtraction? Yes. Is 25x squared a perfect square? Yes. Is 1 a perfect square? Yes. That means this is a difference of 2 squares. So I gave you the formula on this. Remember, to find the difference of 2 squares, you take the square root of both terms, and then you put them into 2 binomials, one with addition and one with subtraction. Why is 1 addition and 1 subtraction? Because that middle term is 0. There is no middle term here. There's only a first and a last term. So here we go. We start by finding the square root of the first term. The square root of 25x squared is 5x. Then we find the square root of the last term. The square root of 1 is just 1. Now we get to put it into our structure. Product of 2 binomials. The first term is going to be 5x because that's the square root of the first term. The second term is going to be 1 because that's the square root of the second term. And one of them is positive, the other one's negative. Why? Because a positive and a negative is how you end up with that 0 term, that missing term in the middle. And that is it. So this was a difference of 2 squares. And you are done. So go ahead and try number 16, which again, hint, hint, it is a difference of 2 squares. The most important thing for you to take out of today is understanding how this flow chart works. To determine which method that you use to factor an expression, you always ask yourself the same first question: is there a GCF? Why do we do that? Because it makes all of your terms a lot smaller, easier to deal with. Then you identify the number of terms in the expression. If it's a binomial, you really only have 2 options. Either it's a difference of 2 squares, or you're done after the very first step. There's only a few ways to be able to factor a binomial. If it's a 4-termed polynomial, you only have 1 option: factor by grouping. That's it. The tough part is when it's a 3-term trinomial. For that part, you have to ask yourself, is there a leading coefficient? So is there a number in front of x squared? If no, you get to use p's and q's. If yes, is it a perfect square trinomial? Now, you don't have to ask yourself this question, but if you look at number 13, it was a lot simpler to do by using this formula. The first and the last term are perfect squares. The middle term is double the product of the square roots of the first and the last term. So just keep that in mind, that it is a lot easier to use. If it's not a perfect square trinomial, you get to use your super grouping, your double cross, or your slip and slide. This flow chart is something that can help you process through. So you'll have access to this flow chart for your assessment. You can use it while you're doing worksheet practice. You can use it while working on the IXL code, etc. All right, that is it for today. I hope that you are keeping up with your schoolwork and participating and doing okay, and that you're safe and healthy. Please email me if you have any questions, or if you need additional time or whatever you need. I am here for you to help in any way possible. Hope you have a great rest of your Wednesday and have fun factoring.